At the end of chapter 2, we formalized a way to find the slope of a curve at a point by taking the limit as some 2 points on the curve got closer and closer, taking the limit of that slope value as the distance between those 2 points got closer and closer to 0. We can use this now. That told us the formula that told us the slope at 1 point. Remember when we did one example where instead of picking an x value to look at, we used a variable, and then we had a formula at the end that we could use to find the slope at any point along that curve. A function that tells you the slope of a curve at any point is called a derivative, and that's the topic of pretty much the whole rest of the first half of calculus, the whole rest of first semester for us. So this is a formal definition for the derivative of a function f. There's a place for it in your notes paper. There's a place for it in your important facts paper. So we say f prime of x, the derivative of f with respect to x is the limit as h goes to 0 of f of x plus h minus f of x all over h. There are lots of different notations you can use for a derivative, and you'll be expected to know all of them for the AP test. Probably the one that you'll see most often is it's called a prime notation. So the derivative of f I call f prime, and I would say f prime x or f prime of x. I can also say the derivative of f with respect to x. Another notation for the derivative means the same thing. I can say df dx, or I can say the derivative of f with respect to x. These all mean the same thing, the derivative of the function f with respect to x, or the slope of the function f, which must be a function of x. Some other notations we could use. dy dx, since f of x is function notation, that letter we use f implies the outputs. Well, y also implies the outputs. So you might instead say dy dx. This is actually the second most common one you'll see. Again, we can also say the derivative of y with respect to x. Or we might just say y prime would be the derivative of y. Okay, this notation is a little bit different. It's a slightly different thing. So I want you to note this one in your notes paper. This notation, the d dx part, we saw dy dx, we saw df dx, but this has d dx. There's nothing after that first d. That is not a notation for the derivative. That is an instruction. That's an operator symbol saying whatever comes after me, take its derivative. So when I put it together with f of x, d dx of f of x means take the derivative of f of x, which you could then call f prime of x or df dx. Sometimes when students just get started with derivative notation, they make this common error, which is that dx implies multiplication. Because before now, every time we bumped up 2 letters next to each other, that implied that they were multiplying. But dx is a brand new kind of symbol. So it does not mean d times x. I'll tell you what it does mean. It means a very tiny change in x. Remember when we talked about remembering the formula for slope, so change in y divided by change in x? But now we want that change in x to get smaller and smaller and smaller and smaller, as like letting h go to 0. So dx means a small change in x, a change so small it's essentially 0. So it's kind of like that h that we've been using. So dx together, those two symbols together, a very small, an infinitesimally small change in x. Similarly, dy means an infinitesimally small change in y. Does not mean d times y. And when I use this notation dy dx, it does not imply division. It's written with a fraction bar. There's going to be special cases in the future where we might be able to treat it like division, but really what that bar means here is separating, well, definitely to make us recall this idea of slope, change in y over change in x. Now, infinitesimally small change in y over infinitesimally small change in x. But that notation now isn't going to imply division, except in the way that it implies the formal definition of the derivative, which is that limit of a difference quotient that we've been working. Once we start taking derivatives the short way, sorry, are you mad? You're not going to be thinking about that as division at all. Similarly, df dx does not mean df divided by dx. It means a very small change in f compared to a very small change in x. All right, this is a really big one. I made you circle it before. It's a common error, and it's a tricky notation. This d up here, there's nothing next to it. We're going to see this symbol a lot, like 10 times a day for the next 8 months. But this doesn't have that y. So this is not a derivative. It's an operator that says take the derivative of whatever comes after me. And so in the same way that sine of pi means take the sine of whatever comes after me. So I can take the sine of pi. d dx of f of x means take the derivative of whatever comes after me. All right, so our first example, we want to use our new definition, a formal definition for the derivative, a function that tells us the slope of some other function at any x value. And we're going to practice using that definition to find these derivative rules. So I copied this definition for the derivative from the notes at the top. I've been told that f of x is a function 3x plus 2. We want to find its derivative. So I'm going to take the limit as h goes to 0 of f of x plus h minus f of x and divide by h. So what does that mean? I need to take x plus h and make it the input to the f function. So the f function takes its input and multiplies it by 3 and then adds 2. So that's what I've done here. 3 times the quantity x plus h plus 2. And I'm going to subtract f of x. Well, here's f of x. Notice I've used these square brackets to help me remember that I'm going to need to distribute the subtraction. Well, once I've done that, I'm going to simplify that numerator. I'm going to see if I can make some things cancel out so that I'll be able to factor and maybe cancel out the h that's in the denominator. And that's exactly what happens. So 3x plus h, 3 times the quantity, x plus h, simplifies to 3x plus 3h. And we're going to, I notice my 3x's cancel, my plus 2 and my minus 2 cancel, and I end up with 3h over h, which I can simplify. Really, this is the limit as h goes to 0 of 3, which is 3. And think about what you already knew. Y equals 3x plus 2 is a linear function. And linear functions, you already knew how to find the slope, right? The slope of y equals 3x plus 2 is 3. So you knew that. And that's what happens here. This 3 isn't just a number. It's a whole function. It tells us the slope of 3x plus 2 at any x value. So that's the cool thing about linear functions is their slope is the same everywhere, which is why when we found the derivative, we got a constant value because the slope of a line, the slope of a linear function is constant. So you've guessed the shortcut, right? From now on, if I ever ask you to find the derivative of a linear function, you're just going to tell me the slope because slope is derivative. Derivative is slope.